Okay, this one will end up having 5 critical points, so it's going to be a long problem. But let's do it one by one. So first, fx is, you're treating y as a constant, you're just differentiating it by x, so it's going to be 4 minus 2x, 8y minus y squared, whereas if you differentiate by y, you're treating x as a constant, and you're just differentiating this, so you get 8 minus 2y. Okay, now I need both of these to be 0, so let's think about what happens if I insist that both have to be 0. The first one will create 4 minus 2x times 8y minus y squared equal to 0, and therefore either 4 minus 2x equal to 0, which means 4 is equal to 2x, giving you x equals to 2, or this has to be 0, which can be factored by y, giving you y equals to 0 or 8. So you have actually 3 possibilities, and the tricky part is just checking each of these cases. You have to figure out what's going to happen for each of these cases. So we're going to have 3 cases. The first case would be when x is 2. If x is 2, then in the second case, when I insist that 4x minus x squared times 8 minus 2y has to be 0, because I'm plugging in 2 in here. 2 times 4 is 8, minus 4, that's going to be 4, times 8 minus 2y equals to 0, but that just means that 8 minus 2y is 0, which is 0 when y is 4, right? So you end up with a 2, 4 as a critical point. Now, case 2, if you set y as 0, that's going to say that this here will be true with y being 0, so it's going to be 4x minus x squared times 8 equal to 0, which gives you x times 4 minus x times 8 equal to 0, but 8 is non-zero, so you just need this, which gives you x equal to 0 and x equals to 4. Alright, so you get, when y is 0, you get x equal to 0, and x is 4, you get 0. So don't get confused with the x and y coordinates. X should come first, so it should be 0, 0, and 4, 0. So these are the critical points. In case 3, when y is equal to 8, when you plug in here, 8 minus 16 is going to give you negative 8, so you're going to end up with times negative 8 equal to 0, but that's still insisting that's 0. We know that's true when x is 0 and x equals to 4. So in that case, we get the points 0, 8 and 4, 8. Alright, so these are the critical numbers, and we have to compute the Hessian and evaluate the Hessian at each of these points. So it's going to be a long problem. Okay, so let's try to compute fxx. First, remember that fx was 4 minus 2x times 8y minus y squared. So if you differentiate this again by x, it's going to be just negative 2 times 8y minus y squared. Whereas y would be differentiating, if you differentiate this by y twice, it's just this one that you end up differentiating, right? So it's just going to be negative 2 here. Because that 8y, if you differentiate twice, it's 0. If you differentiate negative y squared twice, you get negative 2. And then finally, if you want fxy, then you have to take this and differentiate by y, which is 4 minus 2x times 8 minus 2y. Okay, so knowing this, here's our Hessian. Hessian would be all of these combined, right? But since it's too much to write all these, it's probably better to just evaluate the Hessian at each point. Okay, so let's go back to the list of the points. Our points are 2, 4, 0, 4, 4, 0, 2, 4, 0, 4, 4, no, 0, 0, 4, 0, 2, 4, 0, 0, 4, 0, and then there was the 0, 8, and 4, 8. So these are the 5 points. First, let's compute H Hessian of f at 2, 4, and we will take the determinant of it. What is that? That gives you, when you plug in 2 into x, this is going to be 8 minus 4. So that'll be 4 times negative 2. It's going to be negative 8 here. When you plug in 4 here, 16, 32. Oh, that's going to be 32 minus 16, which is 16 times 2, negative 2, so negative 32. And then when you plug in 2 here, it's going to be 0, so HF, these will be 0, 0. Okay, and then this AD minus BC gives you 128 minus 0, so it's 128, which is positive. And because fxx is negative 32, which is negative, which is a frowning face, that means if Hessian's determinant is positive and it's a frowning face, it's a relative maximum. Okay, so we found that 2, 4 is relative maximum. Next one, HF of 0, 0. Well, if you plug in 0, it's going to be 0 here. This will also be 0, but these, if you plug in 0, it's going to be 4 times 8, 32. So it's going to be 0, 32, 32, 0. Let me just clarify. This is same thing as fyx because the second partial is commute. Okay. And then in that case, it'll be negative 1024, which is less than 0. If the Hessian's determinant is less than 0, we know that it's going to be the saddle point. So we found out that 0, 0 is a saddle point. HF of 4, 0, on the other hand, will be, well, when x is 4, this will be 0. 4 times 4, 4 squared, so this will be 0, so fyy will be 0. But when you, oh, and this will also be 0, okay? And then when you plug in 4, 0, that will be 8, but negative 4, oh, it will be negative 32, but again, this will be negative 1024, so it will be a saddle. Okay, I have a feeling that it's going to be the same story with 8. Let's just see. 0, 8. If you plug in 8 into y, it's going to be 0. Yes, just as I thought. So when you plug in 8 here, it's going to be 0. And when you plug in 4 into x or 0 into x, it's going to be 0. So for these both points, you're going to get Hessian's, the diagonals to be both 0. But when you plug in 0 here, it'll be 4. Plugging in 8 will be negative 8. So again, in both cases, you either get 0, 32, 32, 0, or 0, negative 32, negative 32. So in either case, you're going to get saddle. So that means, so I didn't want to write down everything, but here's the answer. Answer is that this function will have at 2, 4 a relative max, and at 0, 0, 4, 0, 0, 8, 4, 8 will all be saddle points. Okay, and then also sometimes the questions might ask you to find the value of the function at the relative max. in that case, you just have to plug in x equals to 2 and y equals to 4. And that's 16, and then what is this? 4 times 16, so 64. So the value of the function here will be 64. So you can also write it as 2, 4, comma 16 in the 3-dimensional space. So that's another possibility. It depends on the question. Sometimes they might just ask you for whether it's the relative max or min. Sometimes they might ask you for the value. That's it.